Now come to the third aspect of the power. So we talked about how you can reduce power. What are the things which are done? Clock gating is the most used example to reduce the frequency. Load capacitance by re-optimizing your logic. Now come to the third part, VGD, and it is most common method because power is directly proportional to the square of VDD. So what do you do is, in this case, you have multi-VDD designs. Okay, by multi-VDD, I mean, let's say there is some part of the design which need not run at the highest voltage you want to give. Let's say highest voltage for this SoC or chip is 1.2. But you can still meet your performance goals by, let's say, lowering the voltage of CPU, lowering the voltage of SoC blocks. You lower this voltage to 1.0, you lower this voltage to 0.9. Because of that, you reduce the power which is being consumed here. And that allows you to reduce the power, overall power of the chip while keeping the performance of the chip. So why performance also becomes a factor when you reduce voltage? So what happens is when you reduce the voltage, right, your current actually will decrease because current is a function of voltage. So your current will decrease. That increases the delay in the gate. Okay, so you lower the voltage, increases the delays on the gate. So you may, by lowering voltage, you may not be able to run your design at the clock speed you want it to run because it will increase the delay. So your setup will become different. Setup time and hold time will become different. So you may not be able to run the design at the same frequency level. So you basically lowering the VDD comes at some performance cost, but maybe some of the logic may not need, you can still meet timing and meet your performance goal with lowering voltage. With, let's say your RAMs are on critical path. Okay. So there you need to use the highest, or cache or on the critical path, you need to use the highest voltage there. But you may be able to meet your chip goals by reducing CPU voltage and SoC blocks voltage and still be able to meet your chip performance goals. So then you reduce power by lowering that voltage. So this is something which when you're designing the architecture, architect has to take these decisions that whether I'm able to meet the performance goals of my chip by reducing some of the blocks voltages. And that is how you design or architect a multi-voltage design or multi-VDD design. So now, how do you reduce leakage current?